Dear students, today's topic is robotics in physiotherapy. Robotics is a branch of technology that deals with the design, construction, operation, and application of robots. And rehabilitation robotics is a field of research dedicated to understanding and augmenting rehabilitation through the application of robotic devices. So, robotics is a branch of technology that deals with the designing and construction, then operation and application, operational application of robots. Basically, robotics can be related to it can solve many it can helpful in many areas, but in we are focusing into the area rehabilitation. So in the area of rehabilitation, it is still in the field of research, and few companies are able to design and construct some of the we will discuss robots which are useful in physiotherapy. We will discuss about that. The well-defined training methods implementing intense multisensory stimulation may induce neural adaptations, what is otherwise called as plus neural adaptations, or as we know as neural plasticity or neuroplasticity, and sometimes called as brain plasticity also, and enhance motor and functional recovery of the paratic upper extremity and lower extremity. Upon this basis, the use of automatic devices was proposed to help therapists to increase the intensity of therapies, produce a multisensory stimulation, and reduce costs during their work. So it helps in aiding multisensory stimulation and also reduces the cost during their work. This new concept dates back to the early 1990s with a new family of robotic machines called haptic interfaces. So the early 1990s, automatic machines were used, automatic machines were used to help and support the intensity, to reduce the intensity of therapies, to produce multisensory stimulation, and to reduce the cost of the work. And these machines were called as robotic machines were called as haptic interfaces. These mechanical devices were designed to interact with the human. So they were designed to interact with the human by guiding the upper limb into passive and active assisted mobilization, helping some movement tasks by biofeedback systems, and measuring changes in movement kinematics and kinetics or forces. So these machines were able to, first thing was that they were able to interact with humans, and they were able to guide the upper limb into passive and active assisted mobilization. So they were able to interact with humans, they were able to do passive movements as well as active assisted movements for the patient, and they were able to helping some movement tasks. So completion of task completion has been help in the area where robotics were helpful using biofeedback systems, mostly EMG related also. So this EMG biofeedback system augmented through the haptic interfaces were able to measure the changes and to record the changes in both kinematics and kinetics, that is movement without forces and movement with forces. So both the kinematic aspect and the kinetic aspect of the movement were able to measure. So a single device was able to do multi-oriented multitask complete area problems were solved. So in a upper limb robotic system classification, according to the classification, were classified according to the part of the upper limb movement, limb on which therapy is focused. So these robots are specifically designed for example, the characteristics according to classification of the which part of the upper limb is used. So unilateral or bilateral shoulder, elbow movement possible, or not possible. Wrist movement only for wrist movement, sometimes only for hand movement. So these kind of, so if some machines will have all this unilateral and or bilateral shoulder movement, bilateral elbow movement, bilateral wrist movement, so all the upper limb movements were possible. And also can be according to their mechanical characteristics. So according to their it can be classified according to the functional classification, how it can be functionally working, or how it is as a machine. We can classify this their to their mechanical characteristics, can be classified into exoskeletal, that is outside the body, something like outside the body, and or the operational machine end effector. So operational machines, like a machine which can be operated by the patient can use the machine to operate something else, or sometimes it acts like a body suit, like a exoskeletal system. According to the control strategy, robots can be programmed to deliver different exercises. In fact, robotic systems are capable of assisting the motion of the patient in a number of different modes, such as passive movement, in which the robotic device moves the patient's arm or maybe even the lower limb; active non-assisted mode, in which the subject executes the exercise and the robot provides no help. So basically here non-assisted mode means the patient will be moving and the robot will only measure the kinetics and kinematics. Active assist mode is, you already know that actively patient will be doing and assisted by the robot wherever the assistance is inadequate. So inadequate, but inadequate, some voluntary but some inadequate movements will be there for the patient. So the wherever there is inadequate movements, the robot will assist. Resistive mode, when the subject is required to perform an exercise against an antagonistic force, provided here the resistance will be provided by the robot. So here it can be used for strengthening also. Bimanual exercises. Bimanual exercises are basically exercises involving the two limbs of the both side, either the upper limb or the lower limb together. So these kind of exercises are basically useful whenever the what you call as synchronization and the what you call as the synchronized movement of both the cortex, especially patients having problem with any corpus callosal injury and all. So they will have difficulty in performing bimanual exercise. So in those cases also robotics can be helpful in a active for in which active movement of unaffected arm is mirrored by simultaneous active passive assisted movement of the affected arms by means of robotic device. So usually without a robot, when we are treating, we will, the therapist may do this kind of activities, and the therapist will try to give feedback to the patients. So these kind of activities can be conducted, can be carried out using a robot. So here the robot can do active, assisted, and actively the patient can do, and the it can be the machine can, the robot can record it, or passive movement or active assisted movement can be provided by the equipment, which is a robotic device. Main electromechanical and robot assisted arm training devices. So we'll just go through some of the names of the machines which are commonly used in the very commonly used in the European and Western countries. So in motion robot is a robot. So here I will we have written DOF. This is a degree of freedoms. So here we are looking into how many active degrees of freedoms are possible. So in motion robot is it's a device where three active degrees freedom of motion is with a wrist robot mounted at the tip of the companion planar robot. MIT Manus is the name of the robot which was developed by MIT. Is a very famous engineering institute in the United States, that is Massachusetts Institute of Technology, and so they have developed a companion planar robot allowing 5 active degrees of freedom at the shoulder and the elbow and the wrist. So this is a wrist mounted robot. It is mounted on the wrist, but it is also able to that is the in motion robots are. So with the companion planar robot, It can increase the degree of motion into 5 active degrees of motions possible. Mirror image movement enhancer, 6 degrees of freedoms, robot manipulator. The treatment focused on shoulder, elbow function, unilateral or bilateral upper limb training. So here the degrees of motions are more. Almost 60 degrees of freedom of motion means shoulder. We only have 6 degrees of freedom. So the whole 60 degrees of freedoms are available in the shoulder as well as to the total. So I think here they are combining both the shoulders and elbows degrees of freedom. So together it has a 6 degrees of freedom of motion. Then you have a bimanual tracker, that is 1 degrees of system to train forearm pronation, supination and wrist flexion extension. So bilateral training in passive or active mode, no feedback to the patient is given. Here it is only this will help in the supination pronation as well as flexion extension of the supination pronation of the forearm and the flexion extension of the wrist. Uh, then you have the gentle uh, uh, equipment, which is otherwise what you call as haptic master, FCS Robotics. It's made in the Netherlands with an extra. So it has 3 degrees of freedom robot manipulator with an extra 3 degrees of freedom. Passive gimbal mechanism allows for supination pronation of the elbow as well as the flexion extension of the wrist. An exercise table, computer screen, overhead frame, and chair. So these are all we are talking about sophisticated, equipments, very highly sophisticated, very costly equipments. Another equipment is arm robot arm in. Semi exoskeleton means half exoskeletal, the half not exoskeletal for movement of the shoulder, where 3 degrees of freedom of shoulder movement. The elbow 1 degrees of freedom, that is flexion extension. Forearm, that is supination, 1 degrees of freedom. Wrist flexion extension, 1 degrees of freedom. So uh, here it's a we can compare this as a very good almost has the same degrees of normal degree of freedom of motion. Shoulder, so 3 degrees means in each axis, that is shoulder flexion extension, abduction adduction, and then internal and external rotation. Together when we combine that we get the circumduction. So in the other one is assisted rehabilitation and measurement guide. Here it's an assisted rehabilitation and measurement. It's also used for like a goniometric measurement. We can measure the kinematics and some also. It is very useful like for feedback and all. So a 4 degrees of freedom, robotic device provides arm reaching therapy for patients with chronic hemiparesis. It gives patient a real time visual feedback of the location of the arm. So the patients who are lacking proprioception and have chronic hemiparesis, these patients very usefully use this assisted rehabilitation and measurement guide. Reha rope therapeutic system. Firstly, for rehabilitation robotics, uses standard industrial robots not modified but equipped with extra safety systems and a special instrumented orthotic developed for fixing the patient's limb. It provides passive shoulder and elbow physiotherapy. It can give passive movement for shoulder and elbow, and it provides a passive shoulder and elbow physiotherapy. So it's actually a repetition. So it provides passive shoulder and elbow physiotherapy movement. Neuro rehabilitation robot, 3 degrees of freedom robot based on direct drive wire actuation. It gives patient visual and auditory feedbacks, easily transportable. So this is a easily transportable device called as neuro rehabilitation robot.